Hello everyone watching this video. Today in this video we will discuss the projectile motion or motion in a plane for NEET and IIT JEE. So before in this video, first we will discuss the projectile motion in brief, and after that we will discuss the type of question are asked in or from projectile motion. So here we have this curve, and this showing the projectile motion. When you throw a ball or any object which goes in horizontal as well as vertical direction, then this motion is cover the plane, and you need to explain this. You need a plane to explain this motion. So that's why this motion is called motion in a plane, and in a simple language this is called projectile motion, and this curve is called projectile. So here we are in this for this motion we need to throw an object at initial velocity that we consider u and at an angle theta from horizontal. Then this velocity is not in horizontal and not in vertical direction. So first we have the component of this initial velocity in the horizontal and vertical direction. So here we have the initial velocity u, and this is the theta component of this initial velocity u. So it will become u cos theta, and the non-theta component of initial velocity become u sin theta. So here in this projectile motion we have one force, which is force of gravity. So this force of gravity only works in the downward direction or in the vertical direction. So this velocity gets changed during this complete projectile motion, but u cos theta remain same at any instant. At any instant, wherever you are, if you are asked that here what is the velocity of the object, we know that there are two components of the velocity, but this horizontal component is always u cos theta. Vertical component we don't know, we will determine that with the given clues. But the horizontal velocity remain constant during the entire motion. And here, so at the initially it when it throws up, its initial velocity in the vertical direction is u sin theta, but gravity works opposite to it, and so this velocity goes on decreasing, and at the highest point the vertical velocity becomes 0, and we have only one velocity, which is u cos theta, and this is the highest point of the velocity, and we call it height of the projectile. And after this point, this projectile or this object goes on, the height of this object goes on decreasing, and it again hit the ground after a certain time. So the distance from it projected and distance where it got to the ground, the distance between the point from it projected and the point where it hit the ground is called the horizontal range, and which is denoted by capital R. And the time duration to complete flight or during the complete flight is defined by capital T, which is shows the time period, or is the symbol of time period. So here we use this property that in this horizontal vertical direction Vy we have the zero velocity, and here initially we have the initial velocity u sin theta. So we use this property that v equals to u plus at, and from here we will determine the time period, because we know the value of a, we know the value of u, we know the value of e, we get the time period of the half motion, and we multiply it with the 2, and we get the time period, and which is, I wrote here, that 2u sin theta by g. You need to memorize all these formulas to become fast. And when you use this time period and get the height of the projectile, you will get the height of the projectile is u square sin square theta by 2g. And when you use this formula or these two formulas to get the horizontal range. You know that you have the time period t and the horizontal velocity u cos theta. You multiply both of that, then you get the range of the projectile, which is 2u sin theta u cos theta by z. And when you use this formula, you take u out, it will become u square, and 2 sin theta cos theta become sin 2 theta by z. So here we have three formula for time period, height and range. The time period and height both depend only on the vertical component of the velocity, because we have sin theta and sin theta. So this all depend, time period and height is depend on the vertical component, but the range depend on vertical and horizontal component both. So sometime in the examination you may get the which component or which quantity depend on the horizontal or vertical component of the velocity. So here you can say the time period and height depend only on the vertical component, whereas the r or range depend on the vertical and horizontal both of the components. So here this is the value of range. So here when you put the value of theta, so 2 theta with maximum can be 90 degree. So here theta become 45 degree, or at that time range become maximum at theta, value of theta is 45 degree, which is u square by z. So for any projectile the maximum range can be u square by g. So this is the fixed value. This is very important. Sometimes you may get the direct question on this formula. What is the formula of maximum range in a projectile? In the NEET it is very important. And sometimes you get at what angle you get the maximum range. So this is the angle for maximum range. Sometimes you get the question like this. You get the question like this. You have this formula and this formula and this formula, and you say that this is the maximum range, then tell the angle of projection, and here you have the angle of projection is 45 degree. So at the 45 degree, or when you throw any object at angle 45 degree, you get the maximum range. At the angle less than 45 degree or more than 45 degree, you don't get the maximum range. You get the maximum range at the angle 45 degree only. So this is very important in point of view of examination. And this is the this type of question are in exams you are asked question directly, sometimes on the time period, sometimes from the height, sometimes from the range. But sometimes you will be confused by the examination or by the examiner, by the question, by giving this angle theta and not giving this angle. So sometimes you get that this angle theta, then this angle become 90 minus theta. So you will put this angle in this all those formulas. So your formulas will be changed accordingly the given angle. So please be careful when you use the theta. So you should be sure that what is your theta or what is your angle. Your angle should be from horizontal. Whatever you are the formula are using, in all the formulas the theta is from the horizontal, not from vertical. So if you are given the theta from here, this angle will become 90 minus theta, and wherever you put your angle you will put 90 minus theta. So that is very important. And sometimes in the examination you are asked to compare the height or time period or range in the two projectile. So here when you get one angle, sometimes you get one angle or say velocity, and you need to compare both of the formulas. So in that case you can use if you are asked that in first case you project at angle at any projectile at angle 30 degree, and second time you project it 45 degree, then tell the height. Then you just need to get the h1 and for the theta 1 and for h2 for theta 2 and put them in the numerator and denominator, and you can get the ratio of that. So this is also very important, the comparison of height, time and range. You should know how to get all these things. So here we have this formula, And now, but you don't get all the time question based on these formulas. Sometimes you are given the basic formulas, or sometimes another situations in which you will use your sense, and you will use the equation of motion in the both of the horizontal and vertical directions. Like sometimes you given the time and you don't know where you are and what they are talking, then you just divide it, the initial velocity in the horizontal and vertical, then use the equation in the horizontal and vertical both of the direction. And always have in mind that your horizontal component remain constant during entire motion, and your only vertical component gets changed. So all the equation of motion use on this, and acceleration always be 0 in that case. And here one more case is given, like in this case when you put the theta and non-theta in the case of range. So here we have one more conclusion, that when you have the angle theta from here, and when you have the angle which is 90 minus theta in both of the cases, when you have angle theta and angle 90 minus theta in both of the cases, you get a equal range. Like for angle 30 degree or 60 degree, you have the equal value of range. Sometimes you ask that when you throw a ball or an object or a stone at angle, initial velocity use something 30 meter per second, anything you will get there. And you are asked that you throw an object at initial or a angle from horizontal 30 degree, and in next time you throw the same object at same initial velocity but the angle is 60 degree, then get the ratio of range for both of the cases. So in both of the cases value of range is same, so ratio will be 1:1. So these are the facts that you need to memorize, so you will be sure in the examination. So this how they ask the question from projectile. It's not tough, it's very quite simple. There are 3 formulas, basic formulas, and you have a horizontal and vertical velocities, and you have equation of motion. You can use them and you can determine the velocity or acceleration or anything at any instant. Like here you get u cos theta, like you determine the velocity something here u y, and here you get u cos theta. But sometimes you are asked to write down or find the actual or exact velocity. That time just use this angle. This angle is 90 degree. So at any instant velocity will be given as under root ux square plus uy square. This is the final velocity at any instant. So just get the velocity in x direction, horizontal direction and vertical direction, and get the final velocity at an instant. So here we wind up today's video for projectile motion, and till that best of luck.